Hello and welcome. Today's lesson is on atoms and matter. Get ready to learn. All kinds of different things to learn today. Why is it important? Well, atoms are the basic building blocks of everything. By understanding the smallest parts of everything, it helps us understand the rest of the universe a little bit more. We can predict what's going to happen when we combine materials because we know about the atoms themselves. And if you've ever wondered why snowflakes look the way they are, it's because of the way that the water molecule is combined chemically. Well, what's important to know about atoms and matter? This guy, Democritus. He's an ancient Greek. He was one of the first to have ideas about atoms. Of course, you don't have a picture of him because it was a long, long time ago, but he figured out that maybe when you took a piece of iron, say, broke it in half, and broke it in half again, and broke it in half again, and again, and again, and again, you would get to something so small that you couldn't break it in half anymore. And he called that atomos, atom. Well, John Dalton, in the early 1800s, he figured out that all matter is made of tiny particles called atoms. And you couldn't break atoms up. Not at that time. Now we can break atoms, but it's very difficult and it's very dangerous. Atoms do not break apart, nor they neither created nor destroyed by ordinary means. You have to go to some real extraordinary means to break an atom. Atoms of different elements differ in mass and other properties. And in a given compound, the combinations of different types of atoms are always present in the same ratio. We'll talk about that a little later. But we know some of these. Water, H2O. 2 hydrogen, 1 oxygen, always. All right, let's talk about the atom itself, atomic particles. Protons, they're located in a nucleus. Nucleus is not a thing, it's a place. It's the center. We can call it the center, but it's actually referred to as the nucleus of the atom. Neutrons are also located in the nucleus. It's called the protons, the blue ones, and the neutrons, the red ones. Electrons orbit the nucleus. These go around the nucleus, kind of like planets going around the sun. The nucleus describes a place where protons and neutrons can be found. That would be in the center here. The nucleus is in the center of the atom, and the electrons orbit the nucleus like planets orbit the sun. Okay? So we've got protons, neutrons, electrons, protons and neutrons in the nucleus, electrons orbiting. So you know most of what you need to know about an atom right now. Now, mass distribution, the amount of stuff. If the nucleus of an atom equaled the mass of a bowling ball, if you've ever picked up a bowling ball, you know what that feels like. The mass of an electron would be then the same as a penny. So electrons don't have a lot of mass. There's not a lot to them. Most of the mass is in the nucleus. That's where the protons and neutrons are. All right, let's talk about the size of the atomic particles. If the nucleus of an atom was the size of an orange, and the orange was on the 50-yard line of a football stadium, the first electron would be the size of this dot. Way over here. So if you put an orange on the 50-yard line, and you had a dot way up here, that's how much room there is inside of an atom. It's mostly empty. All right. What you start with is what you end with. Always. Whatever you start with is what you end with. In a reaction, that's what happens here when atoms combine differently chemically. No new atoms are made or destroyed. If you count the number of just things to the left here, when you start, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. At 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what you start with is what you end with. The chemical bonds break. You see, these are different. And these are the same, but they hang out together. So these bonds break. These are chemical bonds. They share electrons. And they have a reaction here. That's what the arrow stands for. And they recombine a different way. Got the white ones with the red ones and black one with the red ones. The atoms recombine in a new way. They're still there, but they've combined in a different way. New bonds are made. So mass, the amount of stuff, is conserved. Now, matter and energy. Matter can change from a solid to a liquid to a gas by gaining energy. You heat it up. Put it over a flame. Matter can change from a gas to a liquid to a solid. Now we're going the other way by losing energy. We take the heat away. By the way, there is no such thing as cold. There is simply absence of heat. So you can't add cold to gas to get a liquid. What you do is you take out some of the energy. You're said to change state. Many times the change is reversible. If you've ever made ice cubes, you go from a liquid to a solid, and then if you leave them out, they gain enough energy to melt back into a liquid. You could do that all day. Matter is neither created nor destroyed, just changed. Got a solid, it's the lowest energy state. Think about ice. Then you got liquids. They have more energy than solids. They're warmer. Cold as water. And we have a gas. Highest amount of energy. All the particles are floating around, flying around inside the container. That is the hottest. That's water vapor. It's clear. It's transparent. Can't see it. So we have a solid. We don't even need a container for that. A liquid, you need a container, except on Earth, you don't need a lid. But a gas, you need a container all around it to contain it. Keep it in. So why is this important? Atoms are the basic building blocks of everything. Understand atoms and you get an understanding of everything else. It helps us understand our universe. We can predict the outcome of combining materials. And it explains why crystals form and patterns happen. Here's your lesson on atoms and matter.